Welcome to today's topic, design of sections for flexure. This is actually ultimate flexural strength problems. You see, this is the page from IS 1343 1980. Formula is given in page number 15.9. This is for rectangular sections or T sections. Neutral axis falls within the flange. That means, you see, this is the T beam. If the neutral axis falls within the flange, okay, that is the case. This is actually, this is in the web. If the neutral axis falls within the flange, or for rectangular sections, this formula can be used. FPU into AP, this is ultimate tensile strength of cable. This should be calculated from the tables, that is table 11 and table 12. Table 11 for one case, that is it is for pre-tensioned as well as post-tension, but effective bond. This is for not post or with post-tensioned having effective bond. Both is there, pre-tensioned and post-tension. If there is a effective bond, you can go with this table. This table 12 is purely post-tensioned, unbonded. You have to carefully read the problems and understand what type of beam it is, and proper table should be referred. Okay, come to here ultimate tensile strength. This M can be written as MU because this is the formula for MU. Better you write MU, ultimate moment of resistance, okay, or flexural strength. Moment of resistance means flexural strength. Here FPU should be calculated. This AP should be given, D should be given, and XU again should be calculated by using table. This FPU and XU should be calculated. Again M should be calculated, but AP should be given and D should be given, and other dimensions, width and all should be given, and FP is also given. FP is also given. But here your duty is to find FPU and XU. Actually, this is a moment of resistance is, you can call simply a moment. What is moment? Force into distance. What is force? Stress into area is force. This is distance. Actually, we are calling it is a lever arm. I think you studied in your RCC subject. Force into lever arm is called as a moment. Okay, that we are calling moment of resistance. Okay, moment will create a bending effect. Okay, that's called as bending. There is actually resistance against bending, that is called as flexural strength. Okay, after calculating this value, this is called as effective reinforcement ratio. After calculating this value, you refer this table and get what is FPU divided by 0.87p. Here FP is given. FPU can be found. That should be used in formula. Similarly, XU want. Okay. Here again pre-tensioning and post-tensioning is there. You should be very careful. In pre-tensioning, there is no meaning for effective bond. Definitely there is a bond. In post-tensioning, there may be or may not be. We can keep that duct vacant. Okay, that is unbonded. Otherwise, we can fill the grout in the duct then it becomes F bond, okay, with effective bond. Carefully refer, is it pre-tension or post-tension in the examination? You should be very, very careful, okay. Whatever the formula given is for rectangular section or T-beam section, neutral axis within the flange. Suppose neutral axis is in the web, two values will come. Whatever this hatched area, okay, this is one part and this is other part. This strength and this strength combination will be two terms. Whatever this I have written here, FPU into APW, that is for this part, center part, okay. AP into APW into FPU, that is for this part. The second term, whatever I wrote here, 0.45 FCK into B minus BW into DF, actually this is DF, depth of flange. This plus this, actually this overall is B. If you deduct this BW, B minus BW is this width and thickness is DF. This is actually area into stress. Area into stress is a force and this is lever arm, that is moment. Anyhow, two terms are there because of two different areas are there here if the neutral axis falls in the web, okay. I think you understand this. Then how to get APW in this formula? How to get APW in this formula? In the previous case it is directly AP. AP is given, but here there is no term called APW there. APW can be found here. Total area of steel is equal to area for web and area for flange. Now I want APW. To get this one, this is already known, given. To find this one, this should be known. There is a formula for area of steel for flange, that is 0.45 FCK. This formula, you remember, find APF. After finding APF, APW can be found. I think after finding this, you can go for this effective ratio. Reinforcement ratio. Here actually AP into FP is given, okay, sorry, AP into FP is given, but if it is in the web it should be APW, okay. If it is within the web you don't take AP, that's why we calculated APW. APW into FP divided by BW into D into FCK. This is this formula should be used to refer the table instead of APFP divided by BDFCK. Instead of this should be used if the neutral axis falls in the web, okay. And this is for unbounded tendons. Here L by D is important. This as usual, whatever I explained in the previous this one, you can find this one. But here in this unbounded tendons, L by D is important. For a particular value of L by D, FPU divided by FP is there. Okay. There are three values of L by D, 10, 20, 30. Your L by D may fall within 10 to 30. Okay. You have to get what is FPU divided by FP. From this, FPU should be found because FPU is required to find moment of resistance. Similarly, XU by D. To find XU by D, again for different L by D ratio are there. Depending upon L by D value, you can find what is XU by D and then find what is XU, that value you use it. This is the one of the examination problem I gave for the assignment in Google Classroom. Actually, here data given are this. Type is very, very important. Post tension unbonded. It is table 12, page 60. You should come to know that which table should be referred. Sometimes you may refer wrong table. That's why which table should be referred depending upon the type. Okay, B is given 400 mm, small d 800 mm given, AP is given 2840 mm square, FP is given 900 Newton per mm square, small l is 16 meter, FCK is 40. These are all the given data, and MU should be calculated. Okay, this is a rectangular section. Even though the type is this one, this rectangular section is very, very important. Okay, here you must write that one also. Rectangular section. For rectangular section, the formula I shown in the first page itself. It is FPU into AP into D minus 0.42 XU. How to find XU? For that, ratio is there. This effective reinforcement ratio, and L by D you have to calculate depending upon L by D, and for this value and L by D value you have to find what is FPU divided by FP. FPU should be found. Similarly for this effective reinforcement ratio, how much, and depending upon L by D, XU by D should be found, and XU should be taken, and after substituting FPU and XU you can find MU. This is about ultimate moment of resistance or ultimate flexural strength of PSC beams, especially for rectangular and T sections. Okay, thank you.